Okay, everyone, welcome to our webinar today. Before we begin, I want to just let you all know that you're going to be in listen-only mode for the duration of the webinar. So if you have any questions, please enter them in the questions section of the dashboard, and I'll make sure to ask those questions to our two presenters at the end of the webinar. Also, I wanted to let you know that this webinar is being recorded, and so CHBA members will be able to access the recording as well as the PDF version of the slide deck on our website, likely as early as tomorrow. So about our webinar today, as you're aware, the name of the webinar is, Are You Still Air Sealing Your Homes from the Interior? This webinar is really focusing on the level of air tightness that's critical as the first step towards achieving net zero ready performance and ensuring long-term performance and durability of the building envelope. Simply adding more insulation to meet new stringent energy efficiency codes without controlling air leakage could lead to unintended consequences and premature building enclosure failures. So the webinar will cover simple details of Owens Corning innovative CodeBord exterior air barrier system that helps builders achieve exceptional levels of air tightness below 1.5 ACH at the framing stage and provide maximum occupant comfort. So today we have our two speakers would be Sal Charlo from Owens Corning and also Jennifer Weatherston from Reid's Heritage Homes. Based on the names I'm seeing on our webinar list here today, a good chunk of you are probably very familiar with at least one of them, if not both of them. So Sal's job at Owens Corning, he's responsible for the design, certification, and commercialization of complete building enclosure systems for the commercial, industrial, and residential building construction markets. As a civil engineer with more than 26 years of experience in the construction industry, he specializes in high performance and net zero building envelope designs, acoustics, and fire separation systems and solutions. Sal is very active on provincial and national code committees. He has presented educational seminars to architects, engineering professionals, and builders across the country, focusing on next generation building envelope solutions and designs, net zero envelopes, air barrier systems, noise control, and fire protection systems. And Jennifer, as the Director of Innovation and Integration, her role oversees the success of the company's innovation and desire to be forward thinkers. Jennifer has led the product and design teams in advancing the successful path to net zero while demonstrating a strong commitment to advance better building practices from a cost efficiency and production-minded aspect. In keeping with the company's initiative to build better homes and provide optimal value and comfort while ensuring affordability to buyers, Jennifer has worked closely with all aspects of the team to ensure seamless integration and improvement of new practices and processes while continually adhering to the company's core values. So without further ado, I will pass the microphone over to Sal to get us started. Sal?
Thank you so much, Jennifer, and welcome everyone to the webinar. So as it was mentioned on the introduction, the topic of the presentation today is about exterior air barriers and most and foremost, the importance of air barriers as we move towards net zero ready performance of buildings to help ensure occupant comfort, durability, indoor air quality, and obviously energy efficiency. So what I want to talk about today is the different ways to achieve air tightness. I think what we're more familiar with, which is an interior approach, but also talk about an innovative approach, which is air sealing on the exterior and the opportunities and the benefits that that represents. So I'll go over some of the critical details. I'll talk a little bit about the system certification and performance, some advantages to the builder, and I'll share some support tools to help builders and framing crews properly integrate the system into their building envelope designs. Then I'll turn it over to Jennifer to talk about, provide us with some her insight in using and adopting the system in our ECO-EII Net Zero Ready demonstration project, as well as her day-to-day projects. And then we'll open it up to a question and answer period. So just to set a little bit of the context, and I think as Jen mentioned this morning, so we're trending towards mandatory net zero ready performance by 2030, and in order to get there, to get there in an affordable way, what we want to do first is conserve energy before we generate, because on the conservation side, it's more affordable currently with the current technology than on the generation side. So how do we conserve energy? Obviously, it's optimize insulation in walls, attics, and basements, add continuous insulation to eliminate thermal bridges, which represent a lot of potential heat loss, and controlled air leakage, which is really critical, and I'll get into that a little bit deeper. And then obviously, once you've optimized that, you want better windows, move towards triple pane windows, more efficient mechanicals for both heating and cooling, more efficient ventilation, hot water generation, and then integrate some energies that can actually recover energy before you actually go and generate whatever is needed to get full net zero. And I think if we do the first part effectively with current technology, this is where affordability will be achieved. And so if we look at a typical energy profile of a typical two-story single-family home today built to code, on the left-hand side, it's to today's code. And so you can see that most of the energy is used for heating, up to 63%. Then you've got energy used for hot water, lights, and cooling. And as we move towards, we look at a typical net zero house profile, you can see that the heating loads went from like 63% all the way down to like 10 to 13%. So they represent a lot less of the overall loads, and the occupant loads become the ones that are most important. So of that 63% that is currently being used for heating and cooling today, let's take a look at that breakdown. What does that how is it represented? So basically, you can see 25% of that 63% is occurring, energy loss is occurring through basement walls, 5% in attics, 20% in walls, 20% in windows, and 30% of it is attributed to air leakage and ventilation. And so in order to bring that down effectively, the first thing that we want to do is focus on airtightness, because I think with a few critical details, if those are addressed, it's the most cost-effective way to reduce the energy consumption, improve the builder scorecard, and avoid having unintended consequences. So really, the first thing to do on the step to going from 63% energy consumption to like 10 to 13% on the building envelope is much tighter envelope, better basements, better walls, then better windows, and optimized mechanicals. So what I want to focus on over the next series of slides is how to make it tighter, how to make a building tighter, and to benefit from that energy credit that it can provide. So here's a quick snapshot of an energy analysis using HOT 2000, energy consumption analysis using HOT 2000 for a typical home that is built to the current Ontario Building Code. And you can see that in order to get to the net zero energy ready zone, we want to bring the energy consumption of the entire house from like 100 gigajoules or 120 gigajoules all the way down to 56 gigajoules, where it starts to make sense to add panels to start bringing it all the way down to zero. But the point I'm trying to make here is that if you look at builder option package number 1 that doesn't have exterior insulation, because you've got a lot of heat loss through the studs, the thermal bridges, you can see that we're not in that starting zone where it starts to become affordable to get to net zero energy ready. The minute you start adding continuous insulation on the exterior of the structure, you can see the energy consumption or loss goes down significantly. So that's the first good thing. But then if you couple exterior insulation with improved air tightness, you can see the different colors that represent the different levels of air leakage, how in each case, even though you've improved the thermal losses through the structure, if you don't do anything on the if you do something better on the air tightness, you get a significant credit just as well. So it's important to not only insulate better by using exterior insulation to eliminate the thermal bridges along the studs and all of the other structure components, but also to focus on air tightness. And so what are the consequences of uncontrolled air leakage? Well, the most important one is mold growth. So we don't want cavities to get wet, stay wet, where it can promote mold, which can cause issues with interior air quality and occupant health. And so that is the primary concern, and we don't want that to happen. In order to prevent that to happen, we need to make sure that our buildings are airtight, especially as we start insulating them more and more. So if we look at different types of air barrier systems that are out there, so if we look at an interior versus an exterior air barrier system, the one that has typically been used in the industry so far is really an interior air barrier system approach. So you can see it's typically using polyethylene as an air barrier material, which also has vapor barrier properties. And in order to make it an effective air barrier on the inside, we try to make it as continuous as possible throughout the entire interior building envelope. So it's like trying to wrap a gift, a Christmas gift, on the inside of the box. And so, yes, it is doable, and many builders are doing it in an effective way. But there's a lot of transitions, there's a lot of joints, there's a lot of building materials that need to be compatible, that need to come together in order to make that work effectively. But if it's done right, it works well. The other option is to move to an exterior approach. And so if we know and accept the benefit of exterior insulated sheathing, because it actually reduces heat loss through the structure, and we need to control that to get the net zero ready performance by 2030. If we're going to put an exterior continuous insulated sheathing, why not choose one that has the opportunity to also provide the air barrier and the moisture barrier at the same time? And so basically, it's wrapping the home from the exterior, which is much easier to do. There's a lot less critical joints to treat. There's a lot less materials to handle and make sure that compatibility exists between them. And it's a much cleaner approach and provides exceptional levels of airtightness. And so the system that we've developed at Owens Corning and we've put on the marketplace for well over close to 10 years now is our CodeBord exterior air barrier system. And so basically the principal components of that system are extruded polystyrene foam insulation, which is a thermal barrier, an air barrier, and a moisture barrier, not sensitive to moisture. And then we basically seal all the critical junctions. So at the uppermost part of the wall and bottommost part of the wall with a seal gasket that acts as a compression gasket, so that when you nail the foam to the structure, it actually seals that area by compression. And we also tape the joints with an approved tape that's certified by CCMC. And basically now you've got those three control layers from the exterior: heat, air, and moisture control. So what are the benefits of, as I mentioned, exterior insulated sheathing? Well, obviously it eliminates the thermal bridges. So you can see a house that is built on the left that has the same nominal R value, an R24, but with a non-insulated sheathing on the exterior, you can see that the thermal bridges have not been addressed. So if we take that same structure and add insulated sheathing to it, you can see that it significantly reduces the heat loss through the structure, and you get better overall performance. So that's one of the main advantage of exterior insulated sheathing from an energy savings perspective. The second advantage is the risk of condensation. And so basically you can see two walls, one on the left, one on the right on the screen. And the one on the left has insulated sheathing, one on the right doesn't have insulated sheathing. And you can see the stud sheathing interface, the sheathing stud interface temperature in both cases. The one with the foam sheathing is -11 degrees inside the cavity when it's -20 on the outside. And the other one that doesn't have insulated sheathing is almost the same temperature on the inside of the sheet of the wall assembly than it is on the outside of the wall. And so basically you can imagine that if water vapor were to migrate in both of those walls, the one on the right would have the one that has the highest risk of condensation. And so you can clearly see, again, another added benefit of continuous insulation is it reduces the risk of condensation. And so these are just some graphs based on some static dew point analysis. So you can see that basically in Toronto, if we have a wall that's built with 2x6 and R20 bats and non-insulated sheathing, you can see the blue zone. That is the periods where there is risk of condensation, and condensation can occur within the wall. The minute we start adding R value and add thermal resistance to the exterior, that blue shaded area becomes less, and therefore we lower the risk of condensation. This is a wall with R5 on the exterior, and if we add R10 on the exterior, R7.5, it keeps getting lower and so forth. So the more we add on the exterior, the more durable from a risk of condensation perspective the wall assembly becomes. So if we take a look at our air barrier system, again, I mentioned, so if we have a structure, we basically seal the bottommost perimeter of the wall using our seal gasket between the foam and the structure. We use the same seal gasket at the uppermost perimeter of the wall to seal the foam to the structure, and then all the other joints are taped with our approved tape. It's as simple as that. You've wrapped the envelope from the exterior. Now you've got an air barrier, a moisture barrier, and a thermal barrier all in one. So basically achieving all three properties. And once you've done that on the exterior, you no longer need to seal the poly on the inside, because now all you need is a vapor barrier on the inside, and that you can use either unsealed poly or you can go to a vapor barrier paint. And so how do you fasten the insulated sheeting to the structure? So industry has developed many nail guns that are currently available that have adapted to accommodate different thicknesses of insulation, and they basically use an air gun with a nail and a cap washer to actually help fasten the boards to the structure. So I'm just going to walk you through a quick SketchUp file that shows you in a little bit more detail the installation sequence of our CodeBord exterior air barrier system. So if we start at the top of the wall, we start off with a typical seal gasket underneath the sill plate. We build our first floor platform. We install a sill gasket along the header, which is going to help us achieve the airtightness of the foam board that's going to be installed over top of that header. Then we build our walls with our foam sheeting. First story, we build the second story platform. We continue building our walls, and we install our continuous insulated sheeting on those walls. Then we install our header band using insulated sheeting, and then we basically tape all the joints. And once that is done, you're basically airtight on the exterior. The other option is to use a 9-foot board, so we eliminate a taping of a joint along the header. So we only have one horizontal joint that needs to be taped at the second story level. So both options, both formats are available, 4x8 or 4x9. We even have 4x10 sheets. And so once that's done, we are now airtight on the exterior, and we no longer have to provide air tightness on the interior. And so again, just graphically, to summarize the video that the SketchUp that I just showed, so you can see that a seal gasket is basically used at every area where we transition the air barrier from the exterior to the interior. So at the bottom of the wall, we're transitioning the air barrier from our CodeBord exterior air barrier system through the gasket to the wood structure back to the concrete. And at the top of the wall, the uppermost plate, we're transitioning the air barrier from the exterior CodeBord panel through the gasket, through the top plate, into the poly on the ceiling, which it will be sealed to act as both an air and a vapor barrier. And all the other joints are basically taped. And so when you've got some masonry anchors, there's companies like BlockLock that have masonry anchors that are adapted for foam sheeting insulation, as you can see on the screen, or you can use a screw with a metal washer and a corrugated tie for residential buildings. And you can attach vinyl siding through foam sheeting insulation, either direct to foam or over top of wood scrapping. The wood scrapping is recommended so you can narrow the spacing, but also achieve a ventilated drainage plane, which is good from a building science perspective. And you can attach right through the insulation up to 3 inches thick for any type of cladding weight. So there is a lot of research that was done on the attachment of cladding through foam sheeting insulation. It will also be codified. There is a code change request to add additional tables to in Part 9 of the building code. And there's a lot of research that's done on that. Owens Corning does have a technical bulletin that basically is on our website that will show what type of screw, what depth of screw, and what spacing of screw is required to attach cladding through foam sheeting, either with or without scrapping, depending on different cladding weight types. In terms of moisture management around windows, And so basically you can see the detail that's on the screen. So we're using the sill gasket to maintain the air barrier continuity around the rough opening. The foam board gets sealed to the rough opening through the gasket. And then we're using our flashing tape that is approved once again by CCMC or listed by CCMC to act as a flashing tape, and is compatible with our foam board, and that helps manage moisture around the window opening. And so here's another quick SketchUp file of the detail of flashing around the windows. And so if we start off with the rough opening, what we do is we install our sill gaskets around the perimeter. That's gonna, once the foam board is installed and properly nailed, now we've got our air barrier sealed to the rough opening. We install our sill flashing using our approved flashing tape to protect the sill. And then if we install a flanged window, we'll install it in the rough opening, tape the two vertical edges with our approved tape, tape the top horizontal edge, and then install our head flashing and continue to finalize our air seal on the inside with either polyurethane foam or acoustic caulking on all four perimeters. One thing to note here is from the exterior, we do not seal the bottom of the window, so we allow any potential moisture that would get into that space to dry to the exterior, but the entire perimeter of the opening is sealed on the inside to maintain the air barrier continuity. And that is the window moisture management and air management detail with the system. Other opportunity of the system is really to for bonus rooms above garages. I mean, it's important to keep it airtight and also to reduce heat loss through the structure so that occupants feel comfortable. So again, same system can be adopted in the garage space, the garage walls as well as the ceiling. It's our foam board with tape joints that'll achieve the air barrier continuity as well as reduce the thermal bridges. So the system is certified. There is a CCMC listing, and that's important because we've done our due diligence to make sure from a durability perspective that it works. It is approved. It's actually got an A1 classification, which is the tightest system category in the CAN ULC air barrier system standard, and it's good for buildings up to 20 meters in building height. And so on our website at www.owenscorning.ca, we do have a dedicated builder site to that has all the details on our CodeBord air barrier system as well as our builder programs. It's got the SketchUp files that I quickly demonstrated this afternoon. It's also got the series of videos that you can tap into, and it'll show the exact sequence of installing our system and all the critical details at all the different stages. So if we look at the benefits of the CodeBord air barrier system, so first and foremost is it provides obviously a continuous heat, air, and moisture barrier on the exterior that is not affected by wind and water. It is third-party certified, and it does meet the ULC air barrier system standard. So it's easier to achieve and maintain continuity of the air and moisture control layers on the exterior than on the interior. So there's a lot less critical joints, a lot less materials that have to be united together, and much easier to achieve the continuity of the air barrier on the exterior. It provides exceptional levels of air tightness. The system allows a builder to typically come in at under 1.5 air changes per hour at the framing stage. So basically, once the system is installed and the poly on the ceiling is installed and airtight, no bats, no poly on the walls at the framing stage, which is the stage I just described, we're typically coming in, typical values are 1, 1.2, 1.3 air changes per hour. So it significantly helps reduce the risk of condensation. And that's important because as we start adding more insulation in the cavity, it's important to manage that risk. Cost savings to the builder. So we can eliminate the weather barrier because we're taping the joints and we're using a product that is not susceptible to moisture. You can eliminate the header wrap, possibly spray foam and headers, and we'll go back to original bats and a vapor barrier. a lot less detailing and time to seal electrical boxes and outlets on the inside, because all of that sealing is done on the outside. So basically now the vapor barrier on the inside is truly only acting as a vapor barrier, and it can be, you can go from a polyethylene product to a vapor barrier paint. So you can opportunity to replace the polyethylene altogether as a vapor retarder on the interior with a vapor barrier paint, and that helps improve the drying potential, because a lot of the drying potential is not going to occur on the inside as we start to insulate more and more on the outside. So it is not good building science to air seal both sides of that wall, especially not to eliminate the drying potential on both sides of that wall. So again, third-party attestation. We do have CCMC listing, which is important. It confirms that the system works well and is durable under accelerated tests. We've also been installing the system in the field for well over 15 years, and the system is very, very durable. And again, dedicated website, an installation manual, installation videos, and it's actually an app that a framing crew or builder or site super can download, and you can actually look at the installation sequence on site through the construction instruction app, which is where our system is represented. And that's all I had. And with that, I'll turn it over to Jennifer Weatherston, to talk about her experience with Reid's Heritage Homes with the CodeBord air barrier system.
Good afternoon, everybody. So many of you know our company as being part of the EcoEI program, and seeing the listed names, many of them are recognized. And I think a lot of you have already started down this path of investigating opportunities to improve the homes. So we'll flip to the next slide. Part of the initiative for us was just about improving our homes and making them healthier, more comfortable. And a key focus is really around affordability. As much as things have been great over the last little bit in the housing market, we also know that tighter times are coming. Some areas have seen it where customers are now struggling with the financing rates through mortgage companies and different approvals, and now they're looking at different homes. So stressing what their return on investment with these types of homes is very important, and selling the message as well, why these homes are better. And it really does, it starts on the outside, and starting with a conservation first methodology. So start on the outside and then work your way in and learn to sell the value back to the buyers. Next slide. So for anybody that is new to us, we are in Guelph, Ontario. That's where we did our 5 net zero homes. We have since made the initiative to move our sites over to net zero as well. So we have another community that we launched in Guelph that is net zero ready. We've got a community that's opened up in the Thornbury Blue Mountains area of Collingwood. That one as well is net zero ready. And we've been working on our multifamily as well to move the bar a bit on them. Back in 2008 is when we actually started, early 2000s, into the using XPS on the outside of the homes as part of the Energy Star movement. And so we've had some experience, a great deal of experience actually, with putting XPS on the outside of the homes. And maybe it's just selfishly because we've been doing it for so long. When I drive by a site and I see plywood or OSB on the outside of the homes, makes me cringe a little bit. But that's just knowing what the air changes and how challenging it can sometimes be to find solutions for that. But I mean, XPS on the outside is a little bit of a no-brainer, I think. We've been involved a bit with the Ministry of Housing and providing input for the technical committee for the building code, and it's coming. Short of the government's influence and changes, it is coming in the building code. So it's better to learn now and find your cost efficiencies, as opposed to wait until you're being told that you have to do it tomorrow and then not having that chance to find the opportunities in it. Next slide. So part of this, you've seen a bit of it already in Sal's presentation, and that's just showing your space loads. for heating, base loads, water heating, ventilation, and cooling. It really is coming down to the occupants that are living in these homes and their impact overall. So it's really re-educating buyers. The second part is a lot of our buyers today come from a generation, or the millennials that are buying. These are people who have grown up in a world of recycling, and they no longer want to pay for energy conservation. They expect it to be part of the base house package. You've seen in the CHBA's consumer reports what their top 10 needs are, and I believe it was 5 of them in this last report that suggested that energy efficiency is of utmost importance to them. So we have to change to meet the needs of the consumers, and I think that with the XPS on the outside, it really is the easiest place to start. Next slide. As you start developing your homes and you start getting more into energy modeling, you start to really see the reduction of loads in the home, and that starts to reduce the panels. So anybody that is a production builder can appreciate that the more solar panels on your home, the more difficult it's going to be. Your roof area becomes your most expensive piece of real estate on the home, because you have all these panels you have to fit on a tiny little roof, and you can't. So you really have to focus on the house itself and the envelope and bringing those loads down so that you can put less panels on the roof. You start trading off different types of equipment to save on solar panels. One example might be your hot water tank, where you offset it with an air source heat pump, and that takes one panel off the roof. So you start playing around with that. Next slide. Some of what we've also done is we've done a lot of investigation into XPS, especially over the last little bit after the ECO-EI program, and looking at the affordability with XPS on the outside, whether it be 1 inch or 2 inches. There's a number of different wall assemblies depending on your business that can kind of help you get there. We've looked at 2x4 walls, staggered stud, blown insulation. We've looked at spray foam on the interior with the XPS on the outside. We've looked at 1 inch with OSB in between with another inch on the outside to get the R10 on the outside, which I will be quite frank, do not do that. You basically create a sandwich wall for the air to travel between, and then you have to find your other places of where the excuse me, air is going through. Some of the comments here from different team members that have worked out on the site or gone through it. I will say we did a student home build with a high school this past year. We built 4 net zero ready homes in Guelph in one of our communities, and the students built one of them. And that house was done with XPS on the main floor and second floor with the 9-foot sheets. And at framing stage, they were under a 1.5 on their air change. So if students in a high school can do this, then I think that our framing crews can figure it out as well. We all have framer shortages, and that is kind of a little bit of a caveat of all of this change is our industry doesn't change well, and it doesn't change quickly. And everyone is afraid that they're going to train their crews to do this system, and the crews are going to leave or get picked up from another builder. We have to kind of accept that that's the norm. Maybe if we all start training our crews, then they'll all just naturally be aware of how to make these changes in the building industry and take it as an advancement to improve or an opportunity to have a leg up on someone else. Taping of joints is not complicated. I mean, your joints on your XPS are shiplap, or not shiplap, but they're laps, so those seal themselves. The tape is a little bit costly. But as you said, when you get to having it on the exterior of the home, you really reduce the air change. In Guelph, we're looking at we've already been speaking with the city of Guelph to pull the poly off the interior of the homes. And so we're just kind of working through with them. They get a little bit nervous, most building officials, when you start going that path, but they are receptive, and you just have to explain to them and show them why. So engage them early on as opposed to later, so that they're kind of on the same page with you. and using the vapor permeable paint as well, which I know Sherwin-Williams does have a product that meets those specifications. Cabs has made a tremendous difference in our homes and the comfort and the energy. If you care about customer referral and repeat buyers in an area where maybe house sales are not based on housing shortages and demand, but where you want to ensure a foothold for your business, I mean, it makes complete and total sense to address the comfort and the quality of the homes. And by putting the cabs on the outside, it essentially is ensuring that there is quality throughout the build. Devil is definitely in the details. You want to watch your flashing because when the homes are getting airtight, they do have a more difficult time drying out. So those window flashing details are very important. And having your site and your crews trained is important as well. So that construction instruction app is very beneficial on site. I'm not plugging them. I'm just kind of saying, you know, when you get on site and your site super who understands the system and is trained and he's talking to someone, a lot of people respond more so visually. So being able to pull that up out on site and show them and explain to them maybe where they've gone wrong. But also holding your trades accountable. So when the mason is up putting the brick on the wall and your mechanical guy punched a hole through for a vent and he didn't seal it, it's about holding them accountable so the mason fixes it and you back charge your mechanical guy. Unfortunately, some trades don't respond unless you hit their pocketbook. So you just have to kind of set the expectation. Generally, we bring our trades in early when we're trying something new and we engage them in the conversation so that they know why we're going down this path. We know building, but at the end of the day, your trades are your experts in their realm. So just giving them the chance to kind of throw out their thoughts is going to help you down the road. But accountability will be huge. Everybody has to do their part and make sure that if they do put a hole in the wall, whether it be an accident or intentional, that they are sealing those homes. The other benefit just becomes to the overall comfort of the home. I mean, building code is also moving to having under slab insulation in Ontario. So when you start looking at basements and creating a bathtub effect, whether it be putting the XPS underneath the slab and running it up the walls to get that complete system. So now you've put the coat on your home, you've put the hat and the boots, and you've got a complete system where it's a total envelope and it's going to be tremendous for the people that live in it. I think there was a study done by CMHC back in some time ago with the equilibrium homes, and when they went back to talk to the buyers about the cost savings, it wasn't about cost savings, it was about comfort. And if you talk to a lot of the homeowners in these homes today, they will say the exact same thing. So focus on the outside and the conservation will be much more cost effective in the long run. The other thing that I would bring up is when you're putting XPS on the outside, you are going to have to look at jam extensions on your windows just for the placement there. And learning to sell the value to your home buyers and helping them understand what they're getting is another crucial piece that's going to help you. It is going to cost you a bit more money, but in the end, it's probably going to save you a lot more. Next slide, I believe, is my take on our experience. The house in the bottom picture is a 3,200 square foot home we built this past year in our net zero ready site. 3,200 square feet, and it is running at a 46 gigajoules a year. So if someone says you can't build a big house and make it energy efficient, I would challenge them on that. That house does have the cab system on it. We started out with the XPS and put triple pane windows in and looked at our walls and our equipment and quite literally got it down to 46 gigajoules. So 3,200 square feet. It is entirely doable. And that is my input.
Great. Thank you so much, Jennifer, and thank you, Sal. I wanted to now open up the table for questions. So we do have 2 questions that have come in already. So while we're going through those 2 questions, if anyone else on the call has more, feel free to go to the questions section of the dashboard and enter it in there. So we had earlier on in Sal's presentation, we had a question regarding if you do the exterior air barrier, can you still do an interior air barrier? And I believe you might have addressed some of that later on in your presentation, Sal?
Yeah, that's a great question. So yes, from an air leakage perspective, you could. Nothing prevents you from air sealing the walls on the inside and the outside. But what happens is drying occurs through diffusion and air leakage. And so if your wall is airtight on the outside, but not as tight on the inside, and it uses layers that are more vapor open, then you get much better drying. So this is why we kind of say you air seal one side, but technically it's not incorrect to air seal both sides, but you don't want to vapor seal both sides.
Great, thank you so much, Sal. We had another question regarding the vertical joints on the outside. Do they need to be taped?
Yeah, that's another good question. So like Jennifer mentioned, our CodeBord panel or sheeting comes with shiplapped edges on all four sides. And so a shiplapped edge is a water shedding joint, or it's configured to shed water. And so from an air leakage perspective, it's not required as long as it's properly nailed. It'll provide very good air tightness. And from a moisture barrier perspective, it is also not required because of the configuration of the joint that I just mentioned and the fact that the foam board is not susceptible to moisture. However, we recommend to tape it because we're not advocating to add a weather barrier over top of the entire system.
Great, thank you so much, Sal. I've got another question here that says, how are the walls laterally braced?
So the walls are laterally braced either by using OSB as an interlayer between the foam board and the structure, or so if you're in a seismic zone, you would have to do that. If you're not in a seismic zone, you can still use the OSB, or you can use wind bracing, so lateral wind bracing.
Okay, great. And we had another question just come in regarding the jamb extensions on the windows. So I don't know if you both want to address this, but maybe Jennifer, you want to tackle it first. So they're just asking, how did you deal with the jamb extensions on the windows?
With that, we worked with the manufacturer. So on the homes that we were working on, we were working with Geldman windows, and we just coordinated with them and with building knowledge to move the jamb extension so that it moved the window a little bit further out.
Okay, so did your window essentially... Oops, sorry, go ahead, Sal.
Sorry, Sonia, I would echo the same. So in Quebec, continuous insulated sheeting is mandated by code, and it's been mandated by code over the past couple of years. So every new house has a minimum value of insulated sheeting on the exterior. And so what's important there is when you're ordering your windows, just to let the manufacturer know of the depth of the insulation you're using, and it'll automatically be integrated with the jamb.
Great, thank you. And so I know I've heard of these INI windows and Audi windows, and then there's some builders who say they just go right in the middle. So Jennifer, where did you guys land in terms of where your windows are positioned?
Ours went to the outside in a standard location, so we just moved them out a bit. It wasn't too crazy. I don't think the cost for the jamb extensions was very much in the grand scheme of things, but that's how we kind of worked with it.
Okay, and now I know I've heard from a lot of people that consumers actually like the deep windowsills because they can put stuff in the windows like a little house plant or something. Are you getting any that kind of feedback as, I guess, a unintended benefit perhaps of doing that with the windows?
I personally haven't heard of any negative comments on them. I think that people are taking advantage of that as well. It helps sometimes with some window coverings as well, where they want them maybe more recessed within the window jambs as well. Just gives it a little bit thicker, stately look.
Okay, great. We've got 3 more questions here. So how thick of CodeBord on the exterior sealed do I need in order not to install an interior vapor barrier or 6 mil poly?
So you still need to install a vapor barrier. In order to completely eliminate it, that's a difficult question to answer from a generic perspective. We'd have to run a hydrothermal simulation on Woofy. But in general, what we've done some research with George Brown College, and we saw that at 3 inches thick, we could have completely eliminated the poly. However, the building code right now, if we prescriptively follow the code, it still calls for a vapor barrier, but doesn't have to be poly. And so it's got to be any material that's less than 60 nanograms. And the vapor barrier paint that Jennifer alluded to by Sherman-Williams does the job. It's much more vapor open than 6 mil poly, and it gives all the drying potential benefit to the interior versus 6 mil poly.
And our project, oh, sorry, go ahead.
Yeah, no, go ahead. Sorry.
I was just going to say our project in Guelph, where we're working with the city, we're putting 2 inches of CodeBord on the outside of the home and working with the city to just use the vapor permeable paint.
When are you going to find out if they've approved that?
As far as I know, it's approved to move forward. We talked to them before we went into construction mode with it. And we validated like with the air change and where we were targeting to hit. And so they did make that approval. Like I said, I think they're very open as long as you're kind of communicating with them.
Yeah. Okay, that's what I've heard from other builders as well. That's great to hear. So someone has asked, Jennifer, can you provide any idea on how much framing labor cost increased by switching to this system?
We didn't really see an increase in framer labor, but I'd have to probably go back to the early 2000s to see what the hit was back then. If framers are wise, they'll understand that like once they kind of figure it out, they can move fairly quickly through it. And I mean, Owens Corning does offer training to the trades as well, where they'll go out and they'll actually teach your framing crews, and maybe I'm pretty sure you still do that, but they'll teach them and show them. I think any increase that we had back in the early 2000s was, I'm trying to think now. What I would do is I'd probably treat the first house as a by the hour basis, just so that they get a feel for the system, and then kind of make it a little bit of a deal to talk to them a few houses in. I don't think it was more than a couple $100. Definitely not more than 800 to 1,000. That doesn't sound right to me, but you will pay a little bit, but it's not absurd.
Great, thanks, Jennifer. Couple other questions. Apply my last question to both above grade and below grade walls. So that question was in regard, Sal, to not needing an interior vapor barrier. So below grade and above grade.
Yeah, so above grade, like I said, the code still requires a vapor barrier, vapor retarder, but it doesn't have to be sealed if it doesn't act as an air barrier. Below grade, I mean, I think a lot of us are aware that there's a lot of work currently being done to try to relax the requirement for a true vapor retarder in basement, or move to something that's smarter, a smart vapor retarder to basically allow basements to dry, that wet concrete to dry if it gets wet. But there's other ways to address that, such as what Jennifer mentioned, using a low permeance CodeBord sheeting up against the concrete foundation wall, and then building a 2x4 or 2x6 wall with mineral wool insulation in the cavity. So the low permeance foam actually prevents the moisture from coming in, and it also prevents condensation when the vapor drive is reversed. And not requiring poly on the inside allows continuous drying to the interior. So there is it is being investigated, and there is a proposal to change the thinking below grade to move to a smart vapor barrier, or remove it when you can remove it by putting systems that I just described.
I would echo that from experience. You're going to want to watch your basements. Poly will not be your friend as you get down there, and if you are wise and you want to move to the high performance path, you are definitely going to want to look at your options in your basement and some sort of breathable membrane.
Okay, so that actually is a great segue into our next question. It's stated here, Jennifer said vapor permeable and Sal said vapor barrier at less than 60 nanograms for the paint instead of poly, which is required, permeable or not?
The building code says the definition of a vapor barrier material by code is any material that has a vapor permeance of less than 60 nanograms. And so what you need is a material that does not to act as a vapor barrier. So if you're using the paint can't be greater than 60 nanograms. Typical 6 mil poly is 3 nanograms. And the paint typically comes in around 50 or 55. So you can see there's a factor of 16. It's 16 times more water vapor open. So it allows much more drying to the interior than 3 mil poly. So it's got to be vapor impermeable, less than 60 nanograms. That's how it's defined in code.
Okay, great, thanks, Sal. We had a comment here from one of the listeners. Because our market was a little soft, we were able to have our framers install the XPS without a cost increase, where we had 60 units all with full wrap. And I believe that would have been in Saskatoon, not Regina, correct? Let's see if we get a quick answer here. And that was actually the last question I've got on here. So I wanted to ask a quick question of Jennifer myself. So I was pretty interested to hear that there's a lot of things you no longer need to do when you go to this exterior rigid insulation solution. Okay, so yeah, it was confirmed that was in Saskatoon. So Jennifer, there's things like not needing to worry about the insulated gaskets for, you know, the electrical outlets and things like that. Did this system significantly streamline some of those details that you used to have to do before the exterior rigid?
I think that it improved. So when you've got a lot of houses and you're in a frenzy, like maybe last year, and you've got a bunch of new crews who maybe aren't as familiar with the interior detailing, having the cab system saves your butt. Trying to pull those costs back, like the acoustical caulking and the gasket and those sort of things, because for us, we've been doing it for so long, and when we first went that path, we paid a slight premium for that stuff. Over time, you will never get the value, at least it's our experience, you won't get the money back that you paid them years ago as a credit. Everybody's dealing with increases, so they're doing whatever they can to keep what you're paying them. So we haven't seen a great deal of money come out as we've been advancing this last little bit. When you're kind of getting into the nickel and diming, I mean, things like gaskets and gasket boxes or the electrical boxes and that, there is a little bit of an opportunity, but it'll never be as much as what the initial investment was. As well, there's been... Yeah, it's very challenging to claw it back. So that's why if you can get them to be engaged and do a test house at no additional charge and use it as a learning opportunity, then they'll see what the savings in their time is throughout it. But yeah, it's not easy to pull it back out. And I want to say that in Ontario, I think the union trades, and I could be wrong on this, but when they renegotiated their insulation contract in poly, I want to say they wrapped the two together, so the odds of being able to get a credit back on poly install is likely not to happen in Ontario, but I could have one of those facts mixed up.
Okay, great, thanks, Jennifer. We had a question here asked, what is the app that was referred to earlier on that can be used on site to explain to the trade? So it's called Construction Instruction. If you just Google it, they've got all kinds of details, not only on window flashing details and of course the exterior, the CodeBord system. There's obviously there's some details there, but there's a lot of really great details. And what I've heard is especially great about it is because they're animated with no written instructions, there's no need to worry about any kind of translation for any of your crew that might not speak English. So I've heard it's actually a really good app. I've taken a look at some details and some of the animations myself. So yeah, I would definitely suggest taking a look at it.
And Sonia, those are also on our website on the page, the builder page that I showed in the presentation. And the ones that we have on our website are actually, there's a voiceover, and they're available in English and French.
Oh, fantastic. Great. Okay. That's good too. So, you know, having audio obviously is helpful when they're explaining some of the details. So what was the URL for that again, Sal?
www.owenscorning.ca. That's the main web page, and then you just follow the logical clicks to get to the builder page.
Okay, so it's very easy to find the builder page then.
Yes, I can send you the exact URL if you want.
Actually, why don't you, if you can update your slide deck just to put that URL right into the slide deck, and then whoever wants it can grab it right from the slide deck.
Yep, I will do.
Perfect, great. And it looks like we've got one more question. Does Reid's Heritage Homes still use an OSB plywood exterior sheathing or only the XPS and the wind bracing?
Predominantly OSB and wind bracing.
Awesome. Well, I think that's it for the question. So I want to thank our two speakers again today for a great presentation. I also wanted to let everyone know that while I don't have it promoted yet, we do have another webinar coming up on Thursday, November 22nd at 1:30 Eastern. It'll be a ventilation webinar, and we'll have someone from Venmar speaking, as well as Gord Cook, and Doug Terry is going to be our builder representative. And so keep tuned at chba.ca/NZ webinars if you'd like to sign up. There will be a registration link going up there in the next couple weeks. So thanks again, Sal and Jennifer. It was a great presentation. And for those of you who are looking for the slide deck or the recording, they'll be up on our website at chba.ca/NZ webinars, likely sometime tomorrow. Thanks again, and enjoy the rest of your day.
Thank you.
Thank you.
Bye, everyone.